Hello everyone, I am Dr. Santosh Chajed, M.Pharm PhD Pharmaceutical Sciences. In this video, I am going to describe one of the most important reaction of benzene, that is Friedel-Craft acylation. This reaction is discovered by Friedel and Craft, and here one of the hydrogen of benzene will become substituted by acyl group. That's why it is called as acylation reaction. We can obtain phenones, that is aromatic ketones, from this method. So we can say easily that this is the method which is useful for the synthesis of aromatic ketone. So let's start understanding the important reaction when you allow to react benzene with acid chloride in the presence of reagent AlCl3. Formation of aromatic ketones or phenones will take place along with HCl. So here you can easily make out how one of the hydrogen of aromatic ring will become replaced by acyl group. So here acyl group, which will be a electrophile, will become replaced by hydrogen of aromatic ring. That's why this is an example of electrophilic aromatic substitution reaction, where electrophile acyl having a positive charge on the carbonyl carbon will be generated and which will become substituted for one of the hydrogen of aromatic ring. So examples, acetyl chloride is there when it is reacted with benzene in the presence of a reagent AlCl3, formation of acetophenone takes place. So these are called as phenones because phenyl ring become linked to carbonyl carbon directly. Let's try to understand the mechanism of this reaction. In general, there are 5 different examples of electrophilic substitution reactions of benzene is there, that is nitration, sulfonation, Friedel-Craft alkylation, acylation and halogenation, and all of these 5 involved first step, that is formation of electrophile. So in case of Friedel-Craft acylation, acid chloride will react with AlCl3 to form an electrophile acyl ion having a positive charge on the carbonyl carbon, and a conjugate base AlCl4 minus will be generated. So once electrophile will form, it will react with benzene ring. So we know that benzene ring is a source of a pi electron. Ring will share its electron with a electron deficient carbonyl carbon, and as a consequence of that, rhenium ion will form. These rhenium ion will be stabilized by resonance of aromatic ring. These rhenium ion which are formed will react with AlCl4 minus. AlCl4 minus, being a basic in the nature, abstract the hydrogen. As a consequence of that, bond between a ring carbon and hydrogen will broken down and electron will remain behind on the ring carbon, and those electron will be later on will be utilized for formation of carbon-carbon double bond in the aromatic ring, and finally phenone will form or aromatic ketone will form as a product. So when we allow to react a deactivated ring, that is a aromatic ring having electron withdrawing substituent, it will become deactivated. Electron density on such ring will be decreased, and when we allow the reaction between deactivated ring and acid chloride, no reaction will occur, and a possible reason is that this reaction required coordination of a pi electron by aromatic ring with a electrophile which is going to form in situ, and being a ring deactivated, it is not going to share its electron with the electrophile even though it is going to form.